Number 31 says, find the derivative of the function y equals the natural log of x times the square root of x squared plus 7. So they're really trying to get about you using the log properties, okay? You could do just regular old, the derivative of natural log of anything is 1 over that thing times the derivative of that thing, but the derivative of this is going to require product rule. So you'd have to say first times derivative of the second, so 1/2 x squared plus 7 to the negative 1/2 times derivative of the interior 2x plus the derivative of the first, which is 1 times the square root of x squared plus 7. And you could totally do that and write, it's going to have a bunch of fraction work though. The 2's simplify each other out, the x's combine, so you're left with x squared over the square root of x squared plus 7 plus the square root of x squared plus 7 all divided by x times the square root of x squared plus 7. The common denominator would be this, which would be just x squared plus 7. And then once you have a common denominator, this is over 1, you flip and multiply, and then your final answer would be 2x squared plus 7 over, when you flip and multiply, and you multiply x times x squared plus 7 times the square root of that times the square root of x squared plus 7, the common denominator, that would just be x times x squared plus 7, or x cubed plus 7x. Or you can do log properties and say y equals natural log. When you have a product, you can separate using addition. Natural log of x plus, this is natural log of x squared plus 7 to the 1/2 power. And when you take a log of that, you can bring the power down to the front, so 1/2 the natural log of x squared plus 7. And so the derivative would be y prime equals, the derivative of natural log of anything is 1 over that thing times the derivative of that thing, the derivative of x is 1, plus 1/2 times 1 over x squared plus 7 times derivative of x squared plus 7, which is 2x. Final answer, I don't know why I did that. 1 over x plus the 2 simplify each other out, x over x squared plus 7. And I assume that common denominator, if I multiply by x squared plus 7 and I multiply by x, it would get 2x squared plus 7 over x times x squared plus 7. And there you go. Cool. Number 32. Number 32 says, find the equation of the tangent line to the graph of e to the 3x at the point 0, 1. So we need a tangent line to the function y equals e to the 3x at the coordinate point 0, 1. X equals 0, y equals 1. Find the derivative. Y prime equals e to the 3x times the derivative of the interior, which is 3, and the derivative of the power. Plug in the point 0, 1, so plug in x equals 0. X equals 0 means 3 times 0. E to the 0 is 1. That's a 3. There's my tangent line. Okay, cool. Number 32. 33. I don't know what I said. 33 says the displacement from equilibrium of an object in harmonic motion at the end of a spring is y equals 1/6 cosine of 12t minus 1/2 sine of 8t. Where y is measured in feet and t is measured in seconds, determine the velocity of the object when time is pi over 8. So velocity at pi over 8 equals what? So let's find v of t, the derivative. Interesting. Okay. The derivative cosine is negative sine. This is cosine of 12t though, so it's a chain rule. So we say negative 1/6 sine, the derivative of the exterior, cosine is negative sine. Leave the interior alone, but then tack on the derivative of the interior, which is 12. The derivative of sine is cosine, so minus 1/2 cosine. Ugh. That's terrible. Leave the interior alone. Okay. So 8t times the derivative of the interior, which is 8. So I have 12 divided by 6, which is 2, negative 2 sine of, now notice how I didn't put an equal sign because I just don't unless I really want to say that they're equal. So I'm going to go ahead and use this opportunity to go ahead and plug in pi over 8. So 12 times pi over 8. And then this 8 and this 2 simplify down to 4, so minus 4 cosine of 8 times pi over 8. So that's pretty easy. Cosine of pi is -1, so that's just plus 4. 12 pi over 8 is 3/2 pi. So 3/2 pi is down here. And that is the coordinate point 0, -1. Sine is -1, so that's 2 times -1. -2 is -1 anyway. So that's 2 plus 4. The answer is 6. And as far as units go, it's velocity. The position was measured in feet, and time was measured in seconds. So 34. Find dy dx by implicit differentiation. So I've got x squared plus 5x plus 9xy minus y squared equals 4. Find the derivative. So the derivative of x squared is 2x. The derivative of 5x is 5. The derivative of 9xy requires product rule. I'm going to say first times the second. So 9x and then y. So first times the derivative of the second, the derivative of y is y prime, or dy dx, plus the derivative of the first, 9x, the derivative of 9x is 9 times the second, minus 2y times y prime equals 0. Every time you take the derivative of y with respect to x, it's dy dx, but you can take the derivative of x with respect to x, it's dx dx, and that just goes away. It does say solve for dy dx, so 9x y prime minus 2y y prime on dy dx equals, I'm going to subtract everything without y prime in it. So -2x minus 5 minus 9y, and I'm going to factor out a y prime, 9x minus 2y, and I'm going to divide. Y prime equals -2x minus 5 minus 9y, or factor out the negative and put it in front of the entire fraction, divided by 9x minus 2y. And there we go. 35. '35 says use implicit differentiation to find dy dx. And the original function is 7e to the xy plus 5y squared equals 7. So the derivative of 7 e to anything is 7e to that thing times the derivative of that thing. So 7e to the xy times the derivative of xy first times the derivative of second plus the derivative of the first times the second plus 10y times y prime equals 0. I need to solve for y prime. Right now y prime is, one of them is being multiplied by this thing and it's being added to something else, so we need to distribute. So I'm going to rewrite it 7x e to the y prime, e to the xy I mean. So I always put the y prime at the end just because of habit, but you don't have to. Plus 7y e to the xy plus 10y y prime equals 0. I'm going to subtract over the thing without the y prime in it. 7x e to the xy plus 10y, and I'm at the same time going to factor out a y prime, equals -7y e to the xy. And then divide. So y prime equals -7y e to the xy divided by 7x e to the xy plus 10y. And that is your answer. 36. '36 says use implicit differentiation again to find dy dx. So x cubed plus 5 natural log of y equals 4. The derivative of x cubed is 3x squared. The derivative of 5 natural log of y is 5 times 1 over y prime equals 0. So I'm going to subtract the 3x squared and multiply by the reciprocal, which is y over 5. Final answer, y prime equals -3x squared y divided by 5. Number 37. Number 37 says find the second derivative in terms of x and y, just x and y, given x squared plus 6y squared equals 9. Oh, here we go. So in order to find the second derivative, I must first find the first derivative. The derivative of x squared is 2x. The derivative of 6y squared is 12y times y prime equals 0. So y prime equals, I'm going to subtract the 2x and divide by 12y. And that simplifies down to negative x over 6y. And that is my first derivative. So now I'm going to find my second derivative, or in their case, d squared y dx squared. So I'm going to have to use quotient rule. Low, 6y d high, the derivative of negative x is negative 1. Minus high, which is, so that's going to be plus x times d low, which is 6y prime, all over low, which is 36y squared. But the thing about it is that I cannot have y prime in my second derivative. I can have my first derivative, my second derivative. So I'm going to write negative 6y plus 6x times y prime, which is negative x over 6y, all over the 36y squared. The 6's simplify out. The y's combine. I'm going to need a common denominator. My common denominator is going to be y, so I'm going to multiply by y. And that's going to be we'll just go ahead and write here. Negative 6y squared minus x over the common denominator y all over 36y squared. But dividing by 36y squared over 1 is the same thing as multiplying by 1 over 36y squared. So my final answer is going to be negative 6y squared minus x over 36y to the third. And that'll be my final. Although it looks like they simplify with y squared. I'll say the AP exam will have you stop right here. But it looks like what they did was they might have, no, because their derivative has y's in it. They might not have started with the same problem we did. Let me check that on there, sure. So x squared, 6y squared. I forgot my x squared. X times x is x squared. Interesting. If you factor out the negative right here, then you're left with negative 6y squared plus x squared over 36y cubed. X squared plus 6y squared is 9. So that's what they did. Negative 9 over 36y cubed, which is just negative 1 over 4y cubed. Cute! If you stopped here, I'd be fine. If it was an FRQ, as long as you stopped here, you're fine. But unless they said prove that you can get to this expression. But interesting. I don't. Every once in a while, something like that happens, but I wouldn't expect everyone to see that. Okay. 38. I don't have room. So 38 says. Oh, sorry, use logarithmic differentiation to find the derivative of y equals x cubed times the square root of 3x minus 4 over x minus 1 quantity squared. Now, you definitely do not want to have to do quotient rule here because you would have to do quotient rule and product rule, and it would just be a mess. So, and chain. Keep going. So we're going to throw a natural log in front of both sides of the equation. So natural log of this and natural log of all that. And so I've got natural log of y equals. I'm going to bring the powers down to the front as I do it as well. So 3 natural log of x plus, because multiplication, 1/2 because this is 3x minus 4 to the 1/2 power. Natural log of 3x minus 4 minus, because of division, and I'm going to say 2 natural log of x minus 1. And then we're going to find the derivative. So the derivative natural log of y is 1 over y times y prime, because we're taking dy dx. The derivative of 3 natural log of x is 3 over x, because 3 times 1 over x, plus 1 over 3x minus 4, we got the 2 down there as well, times the derivative of, from the 1/2 out front, times the derivative of the interior, which is 3, minus 2 over the natural log. The derivative natural log of x minus 1 is 1 over x minus 1 times the derivative of x minus 1, which is 1. But there's a 2. So y prime equals, I gotta solve for y prime. So in order to get rid of 1 over y, I gotta multiply both sides by y. And y is that original expression. So I've got 3 over x plus 3 over 6x minus 8 minus 2 over x minus 1 times that original expression y. And that would be my final answer. I would not expect you to do common denominator or anything like that. Okay. Number 30, or 39, yeah. So 39 says find the derivative of the function. F of x equals 10. Arc sine is the same thing as sine inverse of x minus 9. The derivative sine inverse of anything is 1 over the square root of 1 minus the function squared times the derivative of the function. So f prime would be 10 over the square root of 1 minus x minus 9 quantity squared times the derivative of x minus 9, which is 1 chain rule. So personally, I'm okay with us leaving it like that. You could say that that's 1 minus x squared minus 18x plus 81 and say 10 over the square root of negative x squared plus 18x minus 80. But I don't think you need to. I mean, they didn't. Bah, whatever. I'll write it just in case you need to. Negative x squared plus 18x minus 80. Okay. 40. Assume that x and y are both differentiable functions of time. Find dx dt when x equals 11, dy dt equals negative 8, the equation xy equals 132. So dx dt is what we're trying to find. When x equals 11, dy dt equals negative 8, and the equation is x times y equals 132. Well, I gotta find the derivative in order to find dx dt, so this requires product rule and the derivative of 132 is 0. First times the derivative, second the derivative of y is dy dt, because we're deriving with respect to time. Plus the derivative of the first, the derivative of x is dx dt, times the second, which is y, equals 0. So I actually know 3 of the unknowns. I know x, I know dy dt, and I actually know y because I can solve. If x equals 11, so divided by 11, let's see, what would that be? 3? 11 times 10 is 110, so plus 22, so 11 times, is that 12? 11 times 12? Duh, because it's got to equal 2. Y equals 12. So 11 times negative 8 plus dx dt times 12 equals 0. We're going to solve for dx dt. So dx dt equals a positive 88 divided by 12, because we're going to add 88 over. Divide by 4 and you get 22/3. Okay. 41. The conical tank with vertex down is 12 feet across the top and 18 feet deep. So 12 feet across the top and 18 feet deep. Okay. If water is flowing into the tank at a rate of 18 cubic feet, so water is flowing. I guess it'll go all the way down to here, and then the water level. Okay. Lighter. There we go. Not that matters, whatever. 18 cubic feet per minute. So dV/dt is 18 cubic feet per minute, and that is a positive because the volume is increasing. Find the rate of change of the depth of the water. Let's find dH/dt. And that height is going to be measured in feet and time is measured in minutes. If I write it there, then I don't have to write it later. When the height of the water is 10 feet, so when height equals 10 feet. So it's saying when the height right here. Now this is the height of the water in general, and this is the radius of the water in general. We don't know what it is. I mean, it's constantly changing. I know at the moment the height is 10, I want to find this, but height is changing, so it deserves a variable. Volume of a cone is pi over 3 r squared h. I want to find dH/dt given h, nothing about r, so if we can replace r from the very beginning, that would be great. Radius is to 6, as height is to 18, which means if I multiply by 18, then I get height equals 3 times the radius. But I think I'd rather have radius in terms of height, so radius is 1/3 the height. So volume actually equals pi over 3, height divided by 3 squared times height, which is height squared over 9. 9 times 3 is 27, so pi over 27 height cubed. dV/dt, the derivative is pi over 9 h squared dH/dt. Power on the front, subtract from the power. Tack on a dH/dt, dV/dt equals 18. Pi over 9, the height at the moment is 10, so that would be 100. And then we're trying to solve for dH/dt. So if I multiply by 9, divide by 100 pi, then dH/dt equals 90 plus 72, 162 divided by 100 pi feet per minute. Obviously that simplifies to 81 over 50, blah, blah. Okay, cool. 42. So 42 says find any critical numbers of the function g of t equals t times the square root of 2 minus t for t less than 2. So g prime of t equals first times the root of the second, which is 1/2 2 minus t to the negative 1/2 times the root of the interior, which is negative 1, plus the derivative of the first, which is 1 times the second. And that is a square root situation, so we're going to rewrite it with negative t over 2 square roots of 2 minus t plus the square root of 2 minus t, which is over 1. And then we're going to do a common denominator. And then you end up with 2 times 2 minus t up here. So that's going to be negative t plus 4 minus 2t, or negative 3t. So negative 3t plus 4 over 2 square roots of 2 minus t equal, well, that's the derivative. As far as critical values go, critical values are when the derivative is 0 or undefined. The derivative is going to be 0 at a positive 4/3. Subtract 4 divided by -3. And at 2, because those are the times that it's 0 and undefined. Oh, but only for t less than 2. So, 2's out. Well, I'm going to put comma 2, but then let's go. Alright. Number 43. Locate the absolute extreme of the given function on the closed interval. So on the closed interval, -60 is 60. Find the absolute extrema of f of x equals 60x over x squared plus 36. Okay. If you're finding absolute extrema on a closed interval, then that is a extreme value theorem problem where your only possible maxes and mins are your endpoints and critical points. So we're going to find our critical points by finding the derivative, and then we're going to do a t-chart. So f prime equals low d high minus high d low all over low. As far as the numerator goes, I'm going to factor out a 60, so let's deal with that. So I'm left with x squared plus 36 minus 2x squared. Yep. So that's going to be negative x squared plus 36 times 60. And as far as the denominator goes, x squared plus 36 is a positive quadratic always. It's x squared shifted up 36 and then you square it. So as far as critical points go, it's never going to equal 0. I don't have to worry about it. So my numerator is just when you take the when you set the numerator equals 0, you can get rid of the 60. Negative x squared plus 36 is just 36 minus x squared, so 6 plus x, 6 minus x. Or negative x plus 6, negative x. Negative x plus 6, x plus 6. Yeah, that's right. Either way, you get critical points at x equals plus and minus 6 from the numerator. So we're going to do a t-chart. Endpoints, -60, critical points, -6, positive 6, and 60. And then we plug them into the original function, whichever one's the highest is the max. Although, I don't see how it couldn't be. Well, okay, interesting. So let's plug in -60. So that's, is that 3,600? 60 squared? That makes sense. So, negative 3,600 divided by, oh my, 60 squared plus 36? Oh, duh, 3,636. That's actually really close to 1. So negative 3,600 divided by 3,636, and you get negative 0.990. If you plug in -6, you get negative 360 divided by 36 plus 36, so that's 72. Negative 360 divided by 72 is -5. Positive 6 is going to be the same thing, only positive 5, and 60 is going to be the same thing as this, only positive, so positive 0.990, which means the absolute max. Yeah, ask for the absolute max or the absolute max location. Huh. Okay. So the absolute max is 5 at x equals 6, and if it asks for the absolute min, then we would say -5 at x equals -6. So next I've got 44. 44 says, given the function 4/3 x times the square root of 3 minus x, determine all absolute extrema on the interval 0 to 3. Oh, 43 does say absolute extrema, not just absolute max. So, absolute min of -5 at x equals +0, 6. No, -6, just kidding. Bye. That's annoying. Bye. Okay. Number 44. You got to do product rule to find the derivative so we can find all our critical points. Although we should know that an endpoint is actually going to be 3. So, anyway, okay. First times 0 seconds, so 1/2, 3 minus x to the -1/2 times the derivative of the interior, which is -1. Plus the derivative of the first, which is 4/3, so plus 4/3 times the second, so square root of 3 minus x. Alright. The 4 and the x and the -1 go on top, so -4x over 3 and 2, so 6, and then the square root, plus 4 over 3, whatever like that. 4 square root of 3 minus x over 3. Common denominator is going to be 6 square root of 2 times the square root of 3 minus x, 2 times the square root of 3 minus x, and that will simplify down to 8 times 3 minus x, which is 24 minus 8x, so 24 minus 12x is the numerator. All over the common denominator, 6 square roots of 3 minus x. As far as critical points go, the numerator will equal 0 when x equals 2, and the denominator will equal 0 when x equals 3. And we're trying to find our absolute extrema on a closed interval, so that's a t-chart, endpoints, and critical points, so 0, 2, and 3, endpoint and critical point. And we plug them in. So if I plug in 0, I get 0, because 4/3 times 0 times anything. When I plug in 2, I get 8/3, 3 minus 2 is 1, so that's just 8/3. And when I plug in 3, I get 0 again. So the absolute max is 8/3 at x equals 2, and the absolute min is 0 at x equals 0 and 3. Number 45. Determine whether Rolle's theorem can be applied to the function f of x equals blah on the closed interval blah. If the Rolle's theorem can be applied, find the numbers. Okay, cool. So Rolle's theorem determines whether or not if your average slope is 0, then at some point your actual derivative will be 0. So 45 says f of x equals x plus 3, x plus 2, quantity squared, on the interval -3 to -2. Well, here's what I know. I know that that this is a continuous function. It's continuous forever because it is a polynomial, and so I'm just going to go ahead and identify it's continuous on the closed interval. And because it's a polynomial, I also know it's is differentiable on the open interval. Now, Rolle's theorem and mean value theorem are the only one that require differentiability because they're the only one that has to do with the derivative. At some point, the actual derivative will equal 0 if the average slope is 0. So the average slope is f of b minus f of a over b minus a. So f of -2 minus f of -3 all over -2 minus the -3. Here's the thing. If I plug in -2, I get 0, so 0 times whatever. If I plug in -3, I get 0 times whatever. So it's 0 minus 0. The average slope is definitely 0. So, Rolle's does apply. And that means at some point the derivative will equal 0 on the interval -3 to -2. Now the derivative right here, I could expand x plus 3 times x squared plus 4x plus 4 and then take a derivative and set it equal to 0. But I'm going to go ahead and use product rule and make it a little bit easier on myself. So f prime of x equals first times 0 second, so chain rule. 2, leave the interior alone, to the first times the interior, which is 1. Plus the derivative of the first, which is 1, times the second, x plus 2, quantity squared. Now, if I'm solving this setting equal to 0, the easiest thing is to factor out an x plus 2. So x plus 2 leaves me with 2x plus 6 plus x plus 2, which is 3x plus 8. And I want to know when that equals 0. This equals 0 at -2 and at -8/3. So -8/3 is the number in between -2 and -3, such that this works. So the answer is going to be x equals -8/3. Okay, 46. '46 says determine whether rules can be applied to x squared minus 13 over x on the closed interval -13 at 13. So the first thing you have to check for rules to apply is continuity. This is not continuous at 0, even though we can split it up. This would still be not defined at 0. So not continuous at x equals 0 rules does not apply. Alright, 47. 47 says determine whether the mean value theorem can be applied for f of x equals x cubed on the interval from 0 to 16. And if it does apply, then work it. So here's what I know. This is a polynomial. That means f is continuous on the closed and differentiable on the open. So therefore it will work. Okay. We need to find the average slope. So that's f of 16 minus f of 0 over 16 minus 0. So f of 16 is 16 cubed. F of 0 is 0 over 16, so that's 16 squared, which is 256. Yeah. So the thing about it is that at some point, the average slope will equal the instantaneous slope, and f prime equals 3x squared. So 3x squared will equal 256 when x squared equals I don't think that simplifies. I mean, it simplifies, but I don't think it. Okay, 256 over 3. So when x equals plus or minus 16 over the square root of 3, or 16 root 3 over 3. But it's only on the interval from 0 to 16, so we're only talking about the positive. X equals 16 root 3 over 3. 48. Okay. Identify the open intervals where the function f of x equals x times the square root of 10 minus x squared is increasing or decreasing. So basically find your critical points, do a sign chart. Now we do need to recognize that this function actually only exists for a short amount of time, but we'll figure that out in a second. All right. So f prime equals first times the derivative second, 1/2 10 minus x squared to the negative 1/2 times the derivative of the interior, which is -2x, plus the derivative of the first, which is 1, times the second, the square root of 10 minus x squared. If you haven't noticed by now, the square root pops up a lot, and it's just one of those things that the more you do, the easier it is. So I've got this -2 and this 2 will simplify down to -1, x times x. So negative x squared over the square root of 10 minus x squared plus the square root of 10 minus x squared over 1, multiplied by the common denominator. And this is what the numerator becomes, negative x squared plus 10 minus x squared. So 10 minus 2x squared over 10 minus x squared. The square root of it anyway. Ew, that's not cute at all. Alright. Where are they getting the, what? Yeah, something about square root of 15, square root of 30. I must have changed the problem because, nah, I won't get those. Okay. Critical points are when the numerator and denominator equals 0. So the denominator is going to equal 0 at plus and minus the square root of 10. And the numerator is going to equal 0 at plus and minus the square root of 5. So if I set that equal to 0, I would add the 2x squared, divide by 2, I get 5, take the square root. If I set this equal to 0, add the x squared, take the square root. There you go. So, in fact, if I try to, well, let me just go ahead and do this. So sign chart. Negative square root of 10, negative square root of 5, positive square root of 5, positive square root of 10. We're going to plug numbers into the derivative, which is this right here, and see what signs I get. So I'm going to plug in a negative square root of, well, it doesn't really matter. It's square root of 11, because I'm going to plug it in and it's going to be squared. So if I plug in a negative square root of 11, I get 10 minus 11. That's a negative number underneath the square root. It does not exist. And neither does it exist over there. The original function doesn't exist over there. So the original domain is literally only from negative square root of 10 to positive square root of 10. So that's my only possibility anyway. Between negative square root of 10 and negative square root of 5 is negative square root of 9. Or negative square root of 8 or negative square root of 7 doesn't really matter because we're squaring. But just whatever. So if I plug in negative square root of 9 and I square it, that becomes a positive 9. 10 minus 9 is 1, so that's positive. Square root of 9 squared, even if it's negative, is going to be 9. 2 times 9 is 18, so 10 minus 18 is negative over positive. That's going to be a negative. If I plug in 0, the denominator is positive. The numerator is, well, actually, the denominator is always positive where it exists. But 10 minus 0 is going to be positive. And then if I plug in the square root of 9 or the square root of 7 or the square root of 6, whatever, let's do square root of 7. I plug in the square root of 7, I get square root of 7 squared, which is 7. 10 minus 14 is negative. And 7 squared, square root of 7 squared is 7. 10 minus 7 is positive, so it's negative. Okay, so this function is increasing from negative square root of 5 to positive square root of 5 because f prime was positive. And is decreasing from negative square root of 10 to negative square root of 5 and square root of 5 to square root of 10 because f prime is negative. All right, that is number 48. Let's do number 49. So number 49 says determine all the open intervals in which the graph is concave up or down. So f of x equals 6x squared over x squared plus 3. Okay, so I need the first derivative, f prime low d high minus high d low over low low. And that's going to simplify to 12x cubed minus 12x cubed, so that goes away, and then plus 36x. So 36x over x squared plus 3 quantity squared. So if I was interested in critical points, then I would say 0 and the denominator never equals 0. So I would say 0. But as it is, I want to know concavity, which means I need the second derivative. So f double prime. Oh. So I'm going to do quotient rule again, only this time when I do quotient rule, I'm going to have to do chain rule when I take the derivative at the bottom. So low, d high, the derivative high is 36. Low d high minus high, d low. D low is 2 times x squared plus 3 to the first times the interior, which is 2x, all over low, x squared plus 3 to the fourth. Now I'm going to simplify out some x squared plus 3's. I actually have 1 in each of these, so one of those with one of those with one of those. So I've got 36x squared plus 108. 36 times 4. 36 times 4. 36 times 4, 120 plus 144. Done. So minus 144x squared. Yeah. All over x squared plus 3 quantity cubed. Although the denominator will never equal 0 because it's x squared plus 3. So as far as possible POIs, I don't really care. 36 minus 144 is negative 108. So I've got negative 108x squared plus 108. If I set that equal to 0, then I really just get x squared minus 1, so x equals plus or minus 1. Okay, I need to do concavity, so I'm going to do negative 1, positive 1, f double prime. So f double prime equals negative 108 times x squared minus 1 over x squared plus 3 quantity cubed. Okay, so when I plug in numbers, I can plug it into the factor formulas. When I plug in negative 2 squared is positive 4 minus 1 is positive. That's times a negative, and that's always positive, so negative. 0, if I plug in 0, I get negative times a negative, that's a positive, and the denominator is always positive. If I plug in 2, I get positive times a negative divided by always positive. So when is this concave up? Concave up from negative 1 to 1. Concave down, negative infinity, negative 1, and 1 to infinity. And if they'd asked for POIs, then I would have said x or f is a POI, or points of inflection, at x equals negative 1 and 1, because f double prime changed sign. 50. So 50 is final points of inflection on the graph. Oh, well, there you go. F of x equals POIs we're trying to find. 1/2 x to the fourth plus 2x cubed. We need to find the first derivative and then the second derivative. So f prime equals 2x cubed plus 6x squared. F double prime equals 6x squared plus 12x. If I factor out a 6x, I'm left with x plus 2. That equals 0 at x equals 0 and negative 2. They both have a multiplicity of 1, which means as far as the polynomial goes, it would change sign at both 0 and negative 2. Technically, you should do a sign chart and do f double prime at negative 2 and at 0. But, I mean, you plug in negative 3, you're going to get a negative times a negative, that's a positive, and then it'll change sign. Okay, so POIs. At 0, 0. So I plug in 0 back to the original, I get 0. And at negative 2, okay. Negative 2 to the fourth, positive 16, so that's 8. And then negative 2 cubed is negative 8 times 2 is negative 16. 8 minus 16 is negative 8. So those are my 2 points of inflection. And that's going to be the end of that video.